I'm actually.
Okay, then give me a pass. All right, so today for our notes, we're talking about some trigonometry. Yes, there is some trigonometry and geometry. So to start off here, the steepness of a hiking trail is often expressed as a percent of grade. The steepest part of Bright Angel Trail in the Grand Canyon National Park has about a 15.7% grade. This means that the trail rises or falls 15.7 feet over a horizontal distance of 100 feet. You can use trigonometric ratios to determine that this steepness is equivalent to an angle of about 9 degrees. Okay, so you can figure out different angles, okay, given certain sides of a right triangle. You can also figure out those different sides given the angles of that right triangle. Okay, that's what we're going to do today. Now, trigonometry comes from two Greek terms, trigon, meaning triangle, and metron, meaning measure. Okay, so the study of trigonometry involves triangle measurement. Okay, so we're still working with some triangles here. Today we're working with right triangles, and we're going to find the different measures in that right triangle. So when I am talking about these ratios, I just call them trig ratios. Okay, they're trig ratios. So it is a ratio or fraction. Okay, so you're going to write it as a fraction of the lengths of two sides of a right triangle. Okay, now when you're using trig ratios, it has to be a right triangle. Okay, it cannot be an obtuse triangle or an acute triangle. It has to be a right triangle. So you need to see that 90-degree angle in your triangle. So again in bold here, right triangles only. The three most common trig ratios are sine, cosine, and tangent. Okay, those are the three that we're going to use. So abbreviation for sine, even though it doesn't need to be, is SIN. It is still called sine. It's not called sin. Sine. Cosine is COS. And tangent is TAN. Okay, you will need your calculator today. So if you have your calculator, get that out for me. So for sine, for any of these, sine, cosine, and tangent, there's always an angle measure attached to them. So it needs to have an angle next to it. So if I say sine of A, it's talking about angle A. Okay, so you take sine of angle A. That would be equal to this ratio of sides. Okay, your opposite side over your hypotenuse. Okay, so if I go from angle A, right, opposite sides are the sides across from. Okay, so from angle A here, opposite would be lowercase a. Your hypotenuse, again, is always opposite your 90-degree angle. Okay, that one will always stay the same. So if I want to write these ratios out, I have sine of angle A. We go from that angle. It'll be our opposite side, so across from, we'll have lowercase a, over the hypotenuse is lowercase c. That would be your ratio of sides for sine of A. Now if I want to take sine of angle B, this time you go from angle B. Okay, you start at that angle. We still need the opposite side, so this side across from the angle we're working with. That's lowercase b. And then over our hypotenuse, again our hypotenuse always stays the same, in this case, lowercase c. Okay, so you're just writing out these ratio of sides. Now, if I look at cosine, again, cosine of an angle, it has to have an angle attached to it. Cosine is adjacent side over the hypotenuse. Now, adjacent, if you remember, means next to. Okay, so it's the side that's next to the angle. That is not the hypotenuse. Okay, so if I want to find cosine of angle A, again, we start at that angle. We need the adjacent side, the side next to it. So there are two sides that are next to that angle, right? But one of them is considered the hypotenuse. So that's not your adjacent side. Okay, your adjacent side would be one of those that make up that 90-degree angle. Okay, so from angle A, the adjacent side would be lowercase b. Okay, that'll be over the hypotenuse. Again, the hypotenuse stays the same in all of these. That would be lowercase c. Now I want to go from angle B. So I want to find the cosine of angle B. So again, we need our adjacent side or side next to. Okay, that's lowercase a right here. Over the hypotenuse, c. Okay, those would be our ratios there for cosine. Now tangent is opposite side over the adjacent side. So this time you don't need the hypotenuse. Okay, so tangent of angle A, so from your angle, you need the opposite side or side across from. Okay, go across from that angle, that's lowercase a. That's over the adjacent side. Okay, the side adjacent to the angle that we're working with. Okay, again, that would be side B. Okay, it's not side C. Side C is the hypotenuse. Okay, so adjacent side would be B. Okay, then tangent of angle B, we need the opposite. Side across from is lowercase b over the adjacent side, the side next to, that's not the hypotenuse, so that would be lowercase a. Okay, questions? So trig ratios are found from the acute angles of a right triangle. I don't know why I put acutes, but it's just acute angles. Okay, from the acute angles of a right triangle. You cannot find trig ratios of the right angle. Okay, if you notice up here, we didn't say sine of angle C, or cosine of angle C, or tangent of angle C. You cannot use that 90-degree angle with your trig ratios. Okay? Because if you tried to do, say, sine, it would be the opposite side over the hypotenuse. That would be the same side. Okay? So we are not using trig ratios with that right angle. So for these next couple here, we're not going to find the decimals, we're just going to find the fraction. Okay, so we want to find the fraction or ratio of each of these down below. What kind of angles are P and Q? Acute. Okay, angles P and Q have to be acute, since that other angle R is a right angle. So from here, we're going to do what we did above. This time they just have numbers. So for number 1, we want to find the sine of angle P. Okay, from angle P, sine is opposite. So go to the opposite side. That would be 15. Over the hypotenuse is 17. Now to help you remember to either use sine, cosine, or tangent, we use SOHCAHTOA. Yes. So where that comes from, we have SO, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse.
Why don't you put your phone over there?
Hello? Yes. Yep.
Why don't you put your phone over there?
Because that's the only place it will plug in.
Actually?
Yes.
So why don't you put
There's
Oh,
a
that's-
specific one
oh,
for
yeah,
the
that's-
phone.
That's brutal.
And I'm right-handed, so I want my stuff over here so I can look at the board. And if I put it over there, I'd be like writing over the top. So we use SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse for ka. And then TOA, we have tangent is opposite over adjacent. Okay, so this is your mnemonic to help you remember sine, cosine, and tangent, what that ratio of sides is. Okay, so SOHCAHTOA. So continuing with these problems here. Number 2 is cosine of angle P. So again, we want to go to the angle we're talking about first. Cosine is adjacent over hypotenuse. Okay, so from angle P, we want the side adjacent to that, or the side next to. That would be 8. And then that is over the hypotenuse, which is 17. Number 3, tangent of angle P. Again, starting at angle P. Tangent is opposite, so go across to that side opposite is 15. Over the adjacent side to that angle, or next to, would be 8. Okay, so we're just writing out these ratios of sides. Questions on 1, 2, or 3? All right, number 4. This time we're working with angle Q. So from angle Q, we want sine. So sine is opposite side, which is 8, over the hypotenuse is 17. 5, we want cosine of Q. So again, working with angle Q. Cosine is adjacent, so the side next to that angle, 15, over the hypotenuse is 17. And then tangent of Q. Tangent is opposite, so from angle Q, the opposite side is 8. Over the adjacent side is 15. Okay, any questions on those?
Do my calculator. Be there for like 10 minutes.
Will you not take calculators? Just give him his
Just sitting
calculator
on
back.
it. I don't. Give it to
Just
me.
give him his
It's under my
calculator back,
leg.
please.
Ew.
All right, so on the back, number 7, I want you to find each of those ratios of sides. Okay? So in your groups, you don't need a calculator for this part. You're just doing what we did on the front, on the bottom there. So write out the ratio of sides for each of those.
Yeah. Right.
If it helps, write SOHCAHTOA at the top of your page. Write SOHCAHTOA at the top of your page so you don't have to flip back and forth. Sine over H, cosine, A over H, tangent over A.
Thank you. Are we gonna have time to go to the Lego space?
Probably not.
You just made my day saying that.
Why?
I wish I was as good at learning this as I was on Thursday. Oh wait, I was coming on Thursday.
Yeah.
I love making fun of them. It's fun. The stats are always so cool.
All right, I'm going to start writing out your ratios here. So sine of k is 12 over 13. Cosine of k is 5 over 13. Tangent of k is 12 over 5. Sine of j is 5 over 13. Cosine of j is 12 over 13. And tangent of j is 5 over 12. All right. Hey, stop. Stop. Now. Any questions on number 7, finding those ratios? All right, so number 8, we want to find the tangent of 30 degrees. Okay, so I need to locate that angle. Okay, that angle's right here. Now tangent, if I write SOHCAHTOA on here, we're using tangent, so we need the opposite side and the adjacent side. So from this angle, we need the side opposite or across from. That would be your O. And we need the adjacent side or the side next to that angle. That's A. Okay, now when I write this out, we're taking the tangent and we're working with this angle 30 degrees. Okay, so we have tangent of 30. That is equal to your ratio of sides. Kenzie, sit down. Your ratio of sides, you have O, opposite, so we have X, over A, or adjacent, is X times the square root of 3. Now, what happens when I have an X over an X? They cancel. Okay, so tangent of 30 will be equal to 1 over the square root of 3. How do I simplify that? I multiply by square root of 3 over square root of 3. Okay, multiply straight across. We have the square root of 3 over 3. Okay, so that is what your tangent of 30 degrees will equal. All right, I'm going to skip number 9 and go to number 10.
All right.
So in number 10, a certain part of a hiking trail slopes upward about 5 degrees. Okay, you can see that in the picture. Sloping upward, okay, that's 5 degrees right there. After traveling a horizontal distance of 100 feet, okay, so horizontal distance right here is 100 feet, along that part of the trail, what would be the change in the hiker's vertical position? Vertical is up and down. Okay, which one of those two variables would we be looking for if I'm finding the vertical position? This one or this one? X or Y? X. Okay, vertical is up and down. Okay, I'm finding that vertical position. Now to do this, I have a right triangle formed here. I know it's hard to see, it got cut off, but that's that little box in the corner of that right triangle. Okay? I'm going to use trig ratios to solve this. Okay, so I'm going to go from the angle we're given. Okay, that's 5 degrees, right? I need to find this side. So that's one of the sides that I need to label. So from that angle, what side would that be? Adjacent, opposite, or hypotenuse? Opposite, it's across from. Okay? So that's the opposite side. I'm going to label it with an O. Now, what's the other side I was given already? That's 100 feet, right? From this angle, what side in SOHCAHTOA would that be? Would that be adjacent? Good. Okay, so looking at my picture now, I have two sides labeled. Kenzie,
What?
sit in your seat, please.
I am in my seat.
Okay, by your desk.
Okay.
I have O and A. Okay, in SOHCAHTOA, that would be tangent. Okay, so if I look back up at my SOHCAHTOA, O and A, I'm going to use tangent. Okay, so we're using tangent. I use this angle right here to label my sides. That's 5 degrees. So we have tangent of 5. Okay, those trig functions there always need an angle attached to them. Okay, they need that angle. That's equal to your ratio of sides. So tangent is opposite. Okay, that's x. Over adjacent, that's 100. And I want to solve for x. So to get x by itself, I need to multiply both sides by 100. Okay, when I do that on the right-hand side, those 100s will cancel. So I have 100 times the tangent of 5 is equal to x. Now I'm going to plug this into my calculator. Okay, so take out your calculator. On your calculator, you'll notice you have 3 buttons that say sine, cosine, and tangent. Yep. Okay, so here, your 3 buttons, you have sine, cosine, and tangent right there. Now I want to plug this into my calculator. So on mine, some calculators are different, so be prepared if you don't get the right answer. I'm going to take 100. I'm going to press tan, and then press 5, and end my parentheses. So on this type of calculator, you can just enter it all in as it shows up. Okay? Press equals, and I get 8.7. Okay? So x will be 8.7, and I believe we were working in feet. Okay, if you did not get that answer, that means your calculator is a little bit different. That means you have to enter things backwards. And I will show you that after I go through the next part of this problem. Okay, so as long, on a quiz or test, okay, as long as you write out this portion, I will not mark it wrong because your process is correct and you got the right answer, and this is the more exact form anyways. Okay? So as long as you write that out, if you get the incorrect decimal, because you don't know how to enter it, it's okay. But I will show you how to do that on a separate calculator after I go through this next part here. So now what we want to find is the distance the hiker traveled. Okay? Up in our picture here, the distance the hiker traveled would be our y value. Okay, I'm finding the y value now. We're going to use this same angle. Okay, so from this angle, this side of that right triangle would be the hypotenuse. Okay, so I'm looking for y. Now again, looking at our picture, we have to decide which one of our trig ratios to use, sine, cosine, or tangent. I'm not going to use this x value here because I rounded to get that. So I have adjacent and hypotenuse. And looking at SOHCAHTOA, we're going to use cosine. Okay, so we're taking cosine of the angle we're working with, that's 5, is equal to that ratio of sides adjacent, so 100, over hypotenuse is y. Now when you're solving these, okay, you always multiply both sides by whatever's in the denominator. Okay, whatever's in your denominator, multiply both sides by that number or that variable. So in this case, you're not multiplying by 100. Okay, you're multiplying both sides by y. Okay, they cancel on that right-hand side because you don't want it in the denominator anymore. So you have y times the cosine of 5 equals 100. Now I still want y by itself. Okay, I still want y by itself. So I'm going to divide both sides by cosine of 5. Now you cannot just divide by cosine. It is nothing without that angle measure. Okay, that angle measure still needs to be attached to it. So on the left-hand side, those cancel. So you have y is equal to 100 over the cosine of 5. Okay, and again, we can plug that into the calculator. So on this one, you can type in 100 divided by, you can press cosine, and then 5 and end your parenthesis. Then press equals. Okay, I got 100.38. Those of you who have the same calculator as me, did you not get 100.38? If you have the same calculator. Okay. When you're doing these trig functions or trig ratios, do you see that little DEG in that bottom right-hand corner on your screen? It needs to say DEG, not RAD. So if it says RAD, that's radians. We're not working in radians. You're working with degrees. Okay? So it should say DEG. All right, so y we got to equal 100.38 feet. Okay, so when working with these problems, you always want to go from the angle that you're given. Okay, one of the acute angles that you're given. So I'm going to do one more problem here, number 11. Okay, so we want to find x in problem number 11. I'm given this angle of 25 degrees. Okay, that's the angle I need to go from. Okay, you go from the acute angle that you're given. Now I want to label the sides of that right triangle, either adjacent, hypotenuse, or opposite. Now from that angle, we have a side across from it. That's the opposite side. And we have the side next to it. Okay, next to it is adjacent. Now we're not given a number for the hypotenuse. Okay, so we don't even need to label that side. You can if you want to, but you don't need to. So in my triangle, I have O and A. So using SOHCAHTOA, that would be tangent. So we're going to take tangent of the angle we went from. So 25, again, that angle needs to be attached to that trig value there. That's equal to your ratio of sides, which is opposite x over adjacent 18. How do we get x by itself? Multiply 18 on both sides. Good. Okay, they cancel on that right-hand side. So we have 18 times the tangent of 25 equals x, and you can enter that into that calculator. So x will be 8.39. 8.4 if you round.
Rounded it to 8.4, but that's still
That would be fine. All right, I need you guys to do number 12. Okay, number 12. If you have a different calculator than me, raise your hand and I'll show you how to plug it into your calculator.
This one's bad. See, Aaron and I used to have our same calculator, and then I switched this year because I was not sure. I just tried this is exactly.
I don't know.
And you'll get a decimal, and then you'll multiply by 82.
You want to, no.
Looking backward. When you're dividing like this one, you're going to press 100, so you still want 100 in the numerator. Divided by, then go backward by cosine. So for ones like this, right, you're going to read it backwards. You're going to take your angle measure first, then press your numerator, you'll get a decimal, and then you can multiply by 0. When you're dividing, like we did this one, you're going to keep that. Press that first. Then divide by, and then again, type in your numerator part backwards. So angle first, and then go back to one side, and then. Who else has a different type of calculator? Anybody?
Oh. Because that's the hypotenuse. Yeah, use cos.
Others have different types of calculators that need some help plugging it in, or you're not in degrees, you're in radians instead.
Well, you have to simplify.
All right, I gave you a little bit of time to work on 12. Yeah.
So if I just write that, like the final answer, that'd be 5 over 10.
Solve for x though.
Yeah, but like that'd be fine.
Well, you still have to get it down to x equals. Once you get it to x equals that value, then yes. All right, number 12. What sides do I have in my right triangle from that angle? From this angle, right? What's this side? Adjacent. What's this side? Hypotenuse. So I have A and H. What am I using? Cosine. Good job. Okay, I'm taking cosine of the angle that I went from, so 70. That's equal to that ratio of sides. So adjacent is 15 over hypotenuse is x. Now again, when you're solving for one of these sides in your ratio, you need to multiply both sides by whatever's in that denominator. Okay, so I need to multiply both sides by x. They cancel on the right-hand side. So we have x times the cosine of 70 equals 15. I can divide both sides by cosine of 70. They cancel on the left. So we end up with x is equal to 15 over the cosine of 70. And you can plug that into your calculator. Okay, and x will equal or be about 43.9 or 86 is fine too. Last thing I want to say, I'm not going to go through 13, but when you multiply both sides, say in this problem by 18, don't multiply 18 and 25 together. Okay? That angle measure needs to stay at 25. Okay? That's an angle measure. The other one is a side length. Okay? That could be in inches or feet or meters or something like that. Your angles in degrees, they're different. Okay? So keep that angle the same throughout the problem. Okay? Don't multiply anything into it. Any questions on our trig ratios?